Okay, so what makes a function and what doesn't make a function? So this is y equals x squared. It's a function. This is a function. An x cubed, that's a function. This y equals e to the power of x. These are exponentials. They are functions. This is not a function. This x equals y squared, not a function. This is a circle. X squared plus y squared equals 4. So this would be like a 2 and 2. It's something that's really important and we study it a bit, but it is not a function. So what now, one way we can look at a function is we can say that any vertical line cuts the curve once, at most once. So this is still a function. This, it cuts it twice, 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 twice. So as soon as it cuts it twice, once, just once, not a function. This, not a function, because this line cuts it twice instead of once. Something like this, let's see is wonder what this would be if it's a straight line here, and we'll include that, and it's a straight line here, and we'll include that point, and then it stops there and it's nothing for those. Is that a function? It's a function here, it's a function here, it's even a function out here. But for this point here, there is two x values. So as soon as an x has two y values, as soon as this x has two y values, the whole thing is not a function. Okay, so we'd have to redefine it if we wanted to make that a function. But this is not a function. It's a function everywhere except for this line here, because that 1x value has two y values. So as soon as one x value has two y values, not a function. So that's in terms of graphs. So every single x value has at most one y value. Every single x value has at most one y value. This exponential, one y value. This, however, this x has two y values. The problem is, given an x, we know what y equals. Given this, given any x, we know what y equals. Given an x here, we don't know what y equals. It could be this or this. That's not a function. Same thing here with not really graphs anymore, but is this a function? This x has one value. This x has one value. This x, one value. This x, one value. One value, one value. This is a function because every single x has one value at most. Can't have two. Doesn't matter if the y has lots and lots of values going to it. This, again, it's a function because every single x has a unique y value. What about this? Nothing goes there. That's fine. That's absolutely fine. Every single x has a unique y value. But if we did this, suddenly this isn't a function anymore because when x equals 2, we could have y equals 3 or 10. Not a function anymore. Okay, it's what we call a relation. Same thing here. If this went to here or here, not a function anymore. Hopefully that, and sometimes you'll see them in set notations like this. This is one set onto another. Okay, and if this goes to here and this one goes to here, this one goes to here, that's a function. That's fine. It would be nice if that went somewhere, and it can go there as well. Okay, but as soon as one of these goes to two spots, not a function anymore. Okay, so that's what a function is, and we tend to study functions. Straight lines are functions, parabolas are functions, as long as they're in this form, y equals x squared. If they're in this form, x equals y squared, not a function. Okay, because again, if y squared is 25, this could be 5 or minus 5. So that's not a function. So every single x value goes to every single y value there is one x value for. Okay, thanks.